Hello, I'm Keenan Maxwell. I'm an instructor with Solar Energy International. I'd like to talk today about a question that I get quite a lot. So I'm making this video for a student of mine in one of the online classes, but I'm going to be posting this video on YouTube, so I want to give a little bit of background first to show you what the question is regarding, and then I'll get to answering this question. So first of all, this is for a battery class. So when we have a battery-based system, we can have power backup. So we've got our utility lines coming over to the house, and that goes into our main panel. That there has a circuit breaker that would go out to our battery system, where we have our inverter. And that goes to the backed up sub panel where you can have more loads. So any loads that you want backed up, you would put in the backed up sub panel. This is the traditional way of doing a system. Yes, there are other ways, and I'll talk about that in a moment. But you'd have your batteries connected here, battery bank, and that's your traditional way that a battery-based system would work. Your solar would then come connected into a charge controller into the battery. So the question was, why do we have, I should say the question that I get asked a lot is, why do we have to have a backed up loads panel? Why can't we just have loads in the main panel and have that backed up? And so we're going to talk about that for a moment. So first of all, when the power shuts off, this unit needs to immediately disconnect from the grid side, and so then it can only put out power in this direction, because if it doesn't immediately disconnect from the grid, then it could end up pushing power out to the power lines, and that would be bad. If you have linemen working out there, that could be very harmful. So not to mention that you're just going to drain your batteries in no time flat, pushing power out to the grid. So it's helpful to look at the inverter internally first. So the traditional battery-based inverter, it's got this power conversion part here, where it takes the battery power in on the DC side, and then it can push out AC power on the AC side. But let's look at it like this. So this is a bigger box that we generally call the inverter right here. But this little portion of this bigger box is really the part that's doing the power conversion. It's taking that DC in, converting it to AC. Here we have our power lines coming in to the AC input terminals, and then we've got our backed up loads on the AC output here. So what happens is there's a switch here inside the inverter, and this is just connected right to its output, and this power conversion part is connected right to here. So when you do have power, when this is connected to those power lines, your switch here will close, connecting it like that, and that will allow that power to go right through to the loads. And this power conversion part here is not necessarily even on. If it is on, it's just pushing out power because the batteries are full, and it's taking that power from the solar and pushing it out to your loads or out to the grid. Or it could be charging your batteries. But basically it's somewhat inactive. It's not active as a voltage source. It's only active as a current source. It just synchronizes and works almost like a grid tie inverter. However, when the grid shuts off, remember, this is not providing voltage, it only provides current. So when the grid shuts off, it's immediately down. So it opens up that switch, so it's disconnected from the grid, And then after that switch opens, then the inverter turns on as a voltage source in its voltage source mode. So that actually has a little bit of a delay, and that's why your lights flicker when the power shuts off, even though they might be backed up by a battery-based inverter. Now this happens so fast that the flicker is only very small, and if you're on a wireless phone, it won't even, I should say a cordless phone, a cordless landline phone, it won't even disrupt the call normally. Your computers don't shut down or anything. It's a really quick system. It's amazing how fast it goes from being essentially inactive to suddenly supporting the load very seamlessly. So this is why this inverter is set up this way. So going back to our typical scenario, we've got our grid power coming into our main panel here. And then from there off one of those breakers into here. However, if you really don't want a backup panel, you don't have to wire it this way. It depends on how the house is wired and everything. But one way that I've seen it done before, many times, I've done it this way myself many times, if you have a separate meter box and a separate main panel, then maybe you have one of these little round meter boxes, or maybe you have one of those meter boxes that has like 5 breakers in it or something. Let's just pretend we've got one of these meter boxes with 5 breakers in it. There's the meter, there's the little breakers. And then before we added any of this, it would have gone from one of these spots over to the main panel. And oftentimes with this type of a system, the main panel might actually be in the house somewhere. In this case, it's really easy. You don't have to rewire very many circuit breakers or anything. You don't necessarily have to make a backed up loads panel. You can tie this into that meter base through one of those breakers, and then tie this end into the top of that main panel in the house. So what are the advantages of doing it this way? Well, first of all, it's a lot less wiring. You don't have to wire a backed up loads panel. If you do it this way, you don't have to worry about, well, did I forget to put the bathroom lights in the backup loads panel or some other critical load? You don't have to worry about it. Everything is backed up. The downside is that this whole unit has to handle the entire load of that main loads panel. So if this is a 200 amp loads panel, your entire system has to be able to handle 200 amps. Whereas if it's just a backed up loads panel, maybe that only needs 50 amps or 30, maybe even 20 amps. So that makes the system necessitates a much larger system right off the bat. Another disadvantage is that because it's carrying all that current through here, if there's not a convenient place to locate this, either really close to the meter or really close to the main loads panel, then sometimes that can end up with a lot of extra voltage drop and a lot of extra wire, therefore a lot more cost, because you have to run really thick wire for this sometimes. So so far we've looked at the traditional inverter used as with a backed up loads panel. We've looked at a traditional inverter doing a whole house backup. Now my student this time asked me about just having the main loads panel. Now I might be misunderstanding him a little bit, but the way I understand the question is he's asking about if you have a main loads panel. Let's turn this back into a main loads panel. And the inverter tied in here. He said, well, can't you just disconnect this breaker here, turn that off so that it's no longer connected to the grid, and then push power from here into the bottom of the main loads panel and there supply the loads that way? And that is very similar to what the next kind of inverter does that I'm going to talk about. There's one more type of a battery-based inverter that is not a traditional inverter, and it works kind of similar to that idea. But to directly answer that question, with this traditional gear, no, that is not possible. Because, and the reason is that they know that somebody could come over here and flip this breaker back on, and suddenly you would be energizing those power lines, and there's some possibility of electrocuting an electrical worker. Of course, there might be ways to jerry-rig it to work, maybe tying this end into that after the power goes out, but in any case it would be illegal and dangerous and a really bad idea if that is your only safeguard, is that breaker protecting those line workers out there from your power. That being said, that's very similar to this next idea. So people started saying, the manufacturers said, well, what if we were to locate this switch, which is controlled by the inverter, what if we were to just remove it, so that's a solid connection, but then install that switch back here? Now obviously this doesn't work if that's the power lines. Let me redraw this a little bit. So if we have our meter base, either one of these, let's just use a round meter base. This could be one of those ones with 5 breakers underneath, but let's just use one of these really old round meter bases with 1 breaker. Doesn't really matter what kind of meter base you have, as long as it's not one of those boxes where the meter base is the same box as the main panel. Those can be difficult to do this way. But as long as your meter base is in a different box than your main panel, then this is easy. So you take that switch out of there and you actually install it after the meter base. And actually, let me do this 2 ways. First of all, I'm going to show it the more traditional way, and then I'm going to show it the whole house way. So if you have a meter base and then you have your main loads panel, then you could come out of here through a switch. Now you cannot flip the switch yourself. It's not manually switchable. This switch is an automatic switch that is controlled by the inverters. And it has safety mechanisms so that if it fails, the inverter knows to shut down. And from here it goes into a sub panel. And this inverter ties into this sub panel. So with this architecture, you actually don't even need more than 1 terminal on your inverter. Your inverter just plugs straight into that sub panel, and then if the power goes out, the inverter and this will communicate together. So when the power's on, this is closed, so everything's being fed from the grid. But when the power goes out, this opens automatically, disconnecting all of the loads that are in this sub panel from the grid, and the inverter supplies those loads. So it's really easy to see. This is a good idea for those smaller systems where you don't necessarily need to handle all of the loads from the house, and because all of the loads from the house might drain the battery too quickly. But for this kind of system, it's really easy to see that you could locate that switch. You could rewire it and locate it up here above, in front of the main loads panel. And now you've got a whole house backup. This inverter can communicate with that switch. As soon as the power goes out, that disconnects the entire house from the grid, and this inverter can then backfeed into the entire house. And you know, if your air conditioner is running or something like that, you're gonna drain your battery very quickly unless your system is designed to run that. But it gives you a lot of flexibility on what you do. With this type of a system, you don't even need this backed up loads panel. You can have it go straight in. And you can control which loads are on and off by flipping breakers inside your main loads panel. One thing that's a really cool idea that's coming out is smart breaker panels that might be able to communicate with your inverter. And when your house is being run by the inverter, they might be able to automatically turn off some breakers. You know, that's kind of in the early stages of being on the market, so it's still a little bit experimental, but really neat ideas. So I hope this kind of helps you see why we generally do need a backup loads panel for most designs, and why it's often advisable to have one, but how there is an alternative. The alternative is a whole house backup, and like we have here. And we have the two architectures. We've got conventional architecture where you've got your AC input and your AC output, and then you have this new architecture which is being used by brands like the Tesla Powerwall. This is how that works. And also Enphase, the IQ8 batteries, this is how that's going to work. And this switch here, the technical term for that switch, according to the code, is a microgrid interconnect device. So I hope that helps. Thank you very much.